Hello, I am Jake Renjo Asho, and this is my performance task number 3 in physical science entitled Video Blog. And the two elements that I chose to discuss on this video are Krypton and astatine. So first, we'll discuss about Krypton. So its melting point is negative 157.33 degree Celsius or negative 251.27 degree Fahrenheit. Its boiling point is at negative 153.415 degree Celsius or negative 244.147 degree Fahrenheit. Its number of electrons is 36. Number of protons is also 36. Number of neutrons in most abundant isotope is 48. Number of valence electron in each shells are 2, 8, 18, and 8. Its electron configuration is 3d10, 4s2, 4p6. Its density is at 0.003708 gram per cubic centimeter. Krypton was discovered in Britain in 1898 by William Ramsay, a Scottish chemist, and Maurice Travers, an English chemist, in residue left from evaporating nearly all components of liquid air. Neon was discovered, a similar procedure, by the same workers just a few weeks later. William Ramsay was awarded the 1904 Nobel Prize in Chemistry for discovery of series of novel gases, including krypton. The name is derived from the Greek word kryptos, meaning hidden. Krypton is gas at room temperature. Solid krypton is white and crystalline. It does not react with anything except fluorine gas. This noble gas is colorless and odorless. It has a full outer shell of electron, rendering it largely inert to reactions with other elements. Unlike its fellow noble gas neon, however, krypton does not make some compounds. The most common is the colorless solid krypton difluoride. Krypton difluoride is only stable below minus 22 degrees Fahrenheit. The Earth's atmosphere is about 0.0001 krypton. Krypton is one of the rarest gases in the Earth's atmosphere. It makes up just 1 part per million by volume. It is extracted by distillation of air that has been cooled until it is liquid. This element is non-flammable, non-combustible, and non-toxic. They can asphyxiate. Krypton is non-metal element. Specifically, it belongs to a group of elements known as noble gases, which are found in group 18 of the periodic table. Because krypton is so rare and thus expensive, it has limited use. The gas is injected to some incandescent light bulbs because it extends the life of the tungsten filament that makes those bulbs glow. The hazards of krypton. Krypton is a rare atmospheric gas. As such, it is non-toxic and chemically inert. The extreme cold temperature will freeze organisms on contact, but no long-term ecological effects are anticipated. This gas is inert and is classified as a simple asphyxiant. Inhalation in excessive concentrations can result in dizziness, nausea, vomiting, loss of consciousness, and death. Death may result from errors in judgment, confusion, or loss of consciousness, which prevents self-rescue. At low oxygen concentrations, unconsciousness and death may occur within seconds without warning. The effect of simple asphyxiant gases is proportional to the extent to which they diminish the amount of oxygen in the air that is being breathed. The oxygen may be diminished to 75% of its normal percentage in air before appreciable symptoms develop. Uses of krypton. Naturally occurring krypton contains 6 stable isotopes. 17 other unstable isotopes are recognized. The spectral lines of krypton are easily produced and some are very sharp. The high cost of obtaining krypton from the air has limited its practical applications. Krypton is used in some types of photographic flashes used in high-speed photography. Some fluorescent light bulbs are filled with a mixture of krypton and other argon gases. Krypton gas is also combined with other gases to make luminous signs that glow in a greenish yellow light. Krypton fluoride is used in certain photographic flash lamps for high-speed photography. Kr has been used as the illumination element of indicator lights of appliances and can be combined with phosphors to create materials that glow in the dark. A patient can inhale gaseous radioactive krypton, which is then absorbed in the bloodstream, enabling the blood flow of the patient to be studied. Movement of Kr can be tracked with a radiation detector to reveal pathways followed by the blood and to quantify blood velocity. Kr isotope 85. Kr has been used in atmospheric monitoring programs to track the effect of atomic facilities on the surrounding environment. Kr is co-generated with plutonium in the fuel elements of nuclear fission reactors and can be monitored at a short distances from an area of clandestine plutonium separation from spent fuel from nuclear reactor. Krypton clarates are prepared using hydroquinone and phenol. Kr can be used for chemical analysis by embedding the isotope in various solids. During this process, kryptonates are formed. Kryptonate is sensitive to chemical reactions at solution surface. It estimates the concentration of the reactants are therefore made possible. Kr isotope 81. Kr has minimal natural production in the Earth, but its concentration in the atmosphere has increased steadily because of human activities related to nuclear industry. Kr enters oceans, lakes, and groundwater through equilibration of water with air. Kr is produced terrestrially as a fission of product nuclear reactors and released into the atmosphere with the novel gases. It is also produced in the atmosphere via the cosmic ray neutron activation reaction. Krypton stable isotopes react in the upper atmosphere by cosmic ray-induced spallation and neutron activation to produce radioactive Kr with a half-life of approximately 2.1 times 10 raised to 5 years. In the atmosphere, Kr is chemically inert and has some long residence time. Because of these characteristics, it is expected that 81Kr has a relatively constant and well-constrained atmospheric source. Natural cosmogenic krypton is incorporated in the air from air into infiltrating groundwater and has been used to determine the age of groundwater over time, scales ranging to over 106 years.